Right. Right now, elimination of internal resistance. Elimination of internal resistance. And electromotive force over there. Elimination of internal resistance and electromotive force. Right. Listen. Right. Listen. Listen. All the experiment. Now these are simple experiment and this is actually simplest one out of all in electricity. Right. Simple means in terms of the apparatus, in terms of the method we use, right? In terms of everything, this is a simple one. In terms of everything, this is a simple one. Right. So first thing, what we are going to have is, right? We are going to have a dry shell, an electric shell, right? To find EMF, and with that, another resistor, a variable resistor, a voltmeter and a meter. Right? So it is like I can only circuit right now, right? The circuit is just like this. The circuit is just like this. Right? We are going to find the electromotive force over there. Right? Then the cell is here. Right? You can change these positions, spaces of these ones as you wish. That's totally fine. Right? And a variable resistor must be here with an ammeter and another fixed resistor. Right? This is a fixed resistor. Right? Say R naught. And this is the variable resistor. Say that is R. Ammeter, or it can be a millimeter as well. Right? There is a switch, say S, and cell ENR. Since we are to measure the potential difference and current passes through the cell, we have to find the voltmeter. Voltmeters are always connected in parallel combination. And since I need to measure the potential difference across the cell, voltmeter should be connected parallel to the cell. Voltmeter should be connected parallel to the cell. Right? Like this. Right? If your connections are clear, doesn't matter how you draw the circuit, right? That doesn't matter because what matters at the end of the day is the connections. Huh? The connections, right? And like the diagram meter the connections are there. Connections are there. Right. So basically, this is what we are going to do. Now, as apparatus, you can now see what we need. See, as apparatus, what we need is this. Now, okay, first materials and apparatus is this. Now, materials are here. Right, we need right here. Right, a voltmeter, an ammeter, a fixed resistor, right, and a variable resistor, right. For this, we can use a rheostat and a tap key, right. So first, mention these things as materials and apparatus. Don't write the circuit, don't take on circuit. First, mention the materials and apparatus. Mention the materials and apparatus one by one. A dry cell. A dry cell. A dry cell. A millimeter. A millimeter. Right? A voltmeter. A voltmeter. These are variable resistor. As variable resistor, what we use is rheostat, right? Rheostat. And usually the range is up to 100. And this is a fixed resistor. That fixed resistor is usually 10 ohms, right? And we need a tap key. We need a tap key. Right, there are reasons to use a tap key or tap key, we'll see. And to connect this circuit, we need connecting wires. Connecting wires. Connecting wires. Right. Listen. Okay. What we do is this. Now after the setup of the circuit, right? After the setup of the circuit, right? We know if this switch is on, there will be a current flow through this loop, right? There will be a current flow through the loop. If this switch is on, if the switch is on, right? The current flows like this. Current flows like this. When we use the voltmeter, right, it is advised to go with the digital voltmeter for the experiment because when it comes to digital voltmeters, they are resistance is very much high compared to analog voltmeters, right? If we are close to the ideal scenario, right, no current will be drawn to the voltmeter. Otherwise, the part of current is going to be absorbed by the voltmeter, right? That's the error that we have in a voltmeter. Open up the voltmeter and the potentiometer is current. That's the reason we use the potentiometer, right? The voltmeter used to, we are using voltmeter, right? And we have two types of voltmeters in labs nowadays as analog and the digital ones, right? Both are fine, but digital one is better because when it comes to digital ones, their internal resistance is very high. They are very high compared to analog, right? When that is very high, that is close to ideal scenario, then no current will be going to this, right? Otherwise, now even if you use the analog one, we are going to negate this current. That's a small current, like a microampere current goes to here. We are going to negate, right? Now, this is what happens. When a current flows out from a cell, see, when a current flows out from a cell, this is the apparatus and the method now. When the current flows out from a cell, what is the equation of a cell? When current flows out, we are going to single cell. When current flows out from the cell, potential difference equals E minus psi. Right? Apply the equation here. Now, electromotive force of the considered cell is E. Electromotive force of the considered cell is E. Right? Electromotive force is E. Then minus say this current is capital line for right. Say this current is capital line. This current is capital line. This current is capital I. Then E minus IR. Fine. Now from these variables, right? From these variables, when I change the resistance here, what is going to change from these variables? What about V? Is it a first tell me whether it's a variable or constant? V? Variable. V is a variable. E is a constant. E is a constant for the battery. E is a constant for the battery. I is a variable. I is a variable because when resistance of the circuit changes, current changes. Now what we are changing is the resistance. Not make but when we change the resistance, accordingly, current changes. Right? And simple internal resistance of the cell is a constant. Right? So always when the cell is designed, E and R are constants. When a cell is designed, E and R are constants. Right? Everything I understand that. Right? E and R are the design values. They are design values. Understand that. Then only variables there are I and V. Right now, when I change the internal, when I change the variable resistor, right? I changes. When I changes accordingly, then the V changes or V changes, right? Which means my x variable should be I. Only possible x variable here is I, right? But potential level is going to stand back. When I changes, only potential changes, right? The potential will stand back. Then we are going to add this as x variable. See? And V as y variable, then equals minus R I plus E. Now the equation is this is our x variable, right? And this is the productive x variable gradient minus mx plus this is going to be a constant. By obtaining minimum of 6 values, right? Between I and V, between I and V, the shape is I equal minus mx plus V. And from the gradient, we can find internal resistance. Some of the targets are done. And from the intercept, we can get the EMF. Right? Which means if you plot a graph, this is done. Right? And now we graph back into this. Then after writing this for the graph, K minimum of 6 values between B and I. B is measured in volts, I is in milliamperes now. Right, I have for a millimeter here, right? I is in milliamperes, and I is the minus mx plus c. The basic shape is like this, right? And minimum have 6 values, 6 readings, and plug the graph. And the intercept here is going to be E, and the gradient here is, right? Gradient here is R. That's negative gradient is R. Right? So if the graph is what? Both are done. Right. Now we have mentioned only the materials. No? Right. Then as separators, mention this. Mention this again. Now always what we need to understand is the connections of this circuit. Understand the connections. Right? All the IT series combination except the voltmeter. Voltmeter is a parallel device. Everything else is series combination. And it's a full series. And these are very potential experiment to come, right? Right. Right, okay, and make your connections clear. And mention this as the theory. Right, after the circuit, mention this as the theory. When you draw the circuit, it doesn't matter whether your switch is on or off, right? Switch off कर दी पर अंदर वहाँ पर इस प्रश्न है नौ रखने हैं but we know that there should be a closed switch when current flows, but when you have drawn the symbol of the circuit, symbol of the switch, right? Symbol is open there, that's fine. Okay, right? Then mention theory also. And mention below the graph, gradient equals gradient. Gradient, simple length equals R, and intercept C equals E. Right? This one is not a, it may be a simple experiment. But in terms of the potential, right, is a very high potential experiment to come. Okay, finished. Okay. Okay. Then let's go to the method. Find out method. 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 Counter method. Write out in point form. First point write out. Connect all devices. Connect all devices. Connect all devices. Connect all devices. As mentioned in the circuit. 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 And make the variable resistor and make the variable resistor within brackets rheostat and make the variable resistor within brackets rheostat infinity infinity and take and take and take voltmeter reading and take voltmeter reading and take voltmeter reading. Listen, that is a precaution. Right, the reason to do that is right if this resistance is set to infinity, right, theoretically there should not be a current. Right? Right? There should not be a current. If there is no current, then across the voltmeter, what should it measure is E no, right? We go to measure E, right? यहाँ भी ये का मतलब check करेंगे ना current क्या होना है, right? अभी तक ये one and बड़ी idea करेगा. Just to get an idea about it, right? Without going the current by setting this to infinity, हम resistor के लेकर set कर लगा. But if you are using the resistor box in boxes, infinite one is there, right? In the rheostat. Not in all rheostats, it is available. You may have people infinite one not compulsory, but we are just getting an idea what P is going to be just by checking the voltmeter reading before starting. Now start before starting. Right now. Then only we are going to start. Now what we do is this. Right here in this rheostat we have a range of 0 to 100. Right. We are going to change this value accordingly as we are taking some milliampere readings. So current readings 25 for each 25 milliamperes. 5 milliamperes. 25 or 30. ये वाले range से रहते right? To change that accordingly, we are using the rheostat. Then resistor box से तो हम own value में हमारा change करना है. But in rheostat we don't have something like that. All the continuous values can be taken. Right? Say we are starting from 100 ring say we are starting from a current of let's say 200 milliamperes, right? Then the second reading is around 175, then 150, 125. Unever readings here current, and we are now taking into like two small values as well, two small, two large values they are right? Then as the next point mentioned, now decrease R, decrease R, decrease R accordingly, decrease R accordingly as millimeter reading, as millimeter reading, as millimeter reading changes approximately by, as millimeter reading changes approximately by, as millimeter reading changes approximately by 25 to 30, 25 to 30 milliamperes, 25 to 30 milliamperes, like 25 to 30 milliamperes, right? Yeah, standard type of 25 milliamperes, like 25 to 30 milliamperes, and record and record and record the readings of current and record the readings of current against potential difference, current against potential difference. given by voltmeter. Current against potential difference given by voltmeter. Right. Now, if you are taking it to a table, the table looks like this. And if you are taking it to a table, the table looks like this. We just need 6 current values. Right. We just need 6 current values. Resistance venas කරාට අපේ value එක ගන්න. Right. Resistance venas කරලා value ගන්න. That is not ignored in the calculation. Right. Our only focus is changing resistance as current drops by 25 milliamperes. That's it. Right. Current changes by 25 milliamperes. Resistance and what we are recording is only I and R. I and V. What we are recording is only I and V because we don't need potential. Sorry, we don't need resistance. 1, 2, 3, 4, 5, 6, like this. Right? Have you stable? That's all you need. Plot the graph. Plot the graph. Plot the graph. Plot the graph. Between V and I. Between V and I. Plot the graph between V and I. Plot the graph between V and I. As discussed under the area. 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 And determine. And determine. And determine. Simple R and capital E. And determine simple R and capital E. Simple R and capital E. Using gradient and intercept. Using gradient and intercept. Using gradient and intercept of the graph respectively. Using gradient and intercept of the graph respectively. Right. So as the experiment, that's it. But about the experiment, this is something here, right? There are like many more minor details asking about these things. Why adaptive issues and why another fixed resistor issues, even though I have a variable resistor here, resistors there, right? For now, what details are. Otherwise, now as the experiment, what we are doing is just this. Right? Experiment is very simple. Right? Why using a digital voltmeter is better than analog one, right? Right? So these things, right? These things are very much important and very much popularly coming into questions. Coming as questions, I think experiment again, otherwise. Now, for the experiment, when this is given, when this experiment is given, around 10 to 12 marks are given. And for other minor details, right, another significant part will be allocated. That is how the nature of this experiment is. Right? Then, major remarks. Consider the reason for using a tap key. What are the keys available? What are the keys available? Pillars, plug keys, and tap keys. Right? Plug keys. Plug keys are the keys that you can switch on by plugging the connector. Plug key plug. Once the plug is plugged, the circuit is connected. Right? That is connected, and that is not going to disconnect again unless you take off the plug. Right? Plug is no going to say. Google one with plug is once the plug is connected, circuit is on. Right? Tap keys means in tap keys, there's a part like this, and another connector here. You have tap this, and connect this to the connector here. Right? Tap करना के लिए you are tapping. Right? मेरे key के लिए नहीं हमारी. Plug key के लिए नहीं हमारी. Right? Plug key सामने जाकर पढ़ाई जो मैंने दोनों ने काम कर दिया ना. Plug key के लिए नहीं हमारी. Plug is like this. Right? And here we can connect a plug. Once that plug is connected, the circuit is connected. Right? And the tap key is like this. In tap key, there is a connector like this, and this is going to connect to here once you tap this. Right? They will tap करना. Once it is tapped only, the circuit is connected. Once you take hands off, this is automatically disconnected. Right? If you need a constant current over a long period of time, right? Which keys we are using then? If we need a constant current over a long period of time, that keys or plug keys? Plug keys. Right? Then that key I want to make a say you are doing the experiment for 30 minutes. So 30 minutes make a there is no convenience. In that case, right? Ever the plug keys. Right? If you need an instant currents. Come now, we are current control. If you need an instant current, we are using tap keys. Right? Tap key and the advantage of using tap keys is, right? We are just pointing the current at the very point that you are taking the reading. Right? And the other times, there is no current passes through the circuit, which means the discharging of the battery, right, or degrading of the battery is minimum. Otherwise, if this key was put on, right, until you are taking all these 6 readings, right, continuously, current flows in the circuit, right? When current flows, then this battery discharges, right? Battery whatever discharge not pass up and right? That's why this is used. Then, again, the readings are higher. You have to tap this only at these 6 points that you are going to take the readings, right? Right? 6 kilo again, anything 6 money, or small, say you are having this for 10 times, that's it. Continuously, the benefit is batteries are going to discharge and degrade. Right? Example, you can use I battery discharge battery. If the battery is degrading, then it changes. Right? Battery discharge, it changes. Battery battery right? Constant that will be constant, right? When we use only. Constant that's why, but tap key is compulsory. Right? Why tap key is used over plug key. Right? Right. First write it down. First point. But tap key is used. A tap key is used. A tap key is used. A tap key is used. If a higher current flows through the circuit, 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 for a longer period of time, but is used if a higher current flows through the circuit for a longer period of time, the battery can be discharged. The battery can be discharged. Within brackets, this can be minimized. This can be minimized. This can be minimized. This can be minimized. When an instant current flows, this can be minimized when an instant current flows. When an instant current flows, this can be minimized when an instant current flows. At the point where readings are taken. At the point where readings are taken. Right. Listen. Next. Right. Very important. This is about this. Now, even though we have a variable resistor here with a range from 0 to 100, right? With a range from 0 to 100, we have a resistor here, right? But yet, we are using another fixed resistor, right? Fixed resistor of 10 ohms, right? The reason is this. Now, when you are decreasing the resistance, right? When you are decreasing the resistance, if it is decreased too much, there is a possibility of passing a higher current through the emitter. If there are higher current passes through emitter, one means there is a possibility of burning out the emitter. Because galvanometers and ammeters, they are very sensitive instruments. अभी meter conversion चल रहा है, moving coil meters, right? Galvanometers के लिए they are very sensitive. They are very sensitive. But pick up here plus if a higher current passes, the heat dissipation of the circuit is higher. Right? Because circuit का रास्ता ना, heat dissipation is higher. यहाँ अपने बैठने के unwanted heat dissipation है क्या? To avoid those, this resistor is also used to control the maximum current. To control the maximum current. The main resistance है क्या? अभी zero आ गएगा पुनः, but still there is a techno resistor working in the system. Right? That's all. आता अभी rheostat के मेगा इलेवन लगा दी, आधे के बाद zero चा टक्कर लो करंट है flow ये करंट है मेगा रूबियो या maximum मेगा exceed the right now expensive. I mean it's not expensive, right? It will be burnt out. Right? Next point. Right? Even if the current is too much, the current cannot be too much high or too much low. Right? If it is too much low, right, there's another problem arises because now we are using an unideal voltmeter. Ideal voltmeter is then there's a small amount of current. There's a small amount of current which passes through the voltmeter also, even though we have neglected. Right? Now we have neglected that microampere current with respect to some milliameter current, right? If my current flows in the circuit is also very small, can we neglect it reasonably? For a small value, small value, small value neglect compared to the millimeter values, micro can be neglected. I mean, micro current can be neglected because the errors are high, or fractional errors are there. Correct? Under too much, that's why 10 ohm is used, right? When some resistors are resistors area, there are 10, 50, 100 these are fixed resistor also suitable resistor as the fixed resistor, right? 10, 50, 100 resistor, right? Then you have to know that the value is 10 is a kind of a average value. 100 the current right? When it is dropped, you can't neglect the current close to the voltage. Body current है, body current क्या है? That's a considerable value. Current body again, that's negligible. That's how we can neglect it, right? Next point, mention. All these points are very important. Next point, mention. A fixed resistor of 10 ohms. A fixed resistor of 10 ohms. A fixed resistor of 10 ohms is used to control the maximum current, which flows in the circuit, For the same point, but this resistor should not be a higher resistor. But this resistor should not be a higher resistor since if current drops drastically, the small amount of current close to voltmeter, the small amount of current, close to small amount of current, close to non-ideal voltmeter, close to non-ideal voltmeter, close to non-ideal voltmeter. Cannot be neglected. Cannot be neglected. Cannot be neglected. Cannot be neglected. Right. Next. Right. Now, when you are choosing voltmeters, practically, right? Over the analog one, digital one is better because in digital voltmeters always the ranges are high. Since the ranges are high, there are resistance, internal resistance are very high compared to analog ones, right? Higher internal resistance, lesser the current it goes through this, no? Which means lesser the error reading, right? Lesser the error reading, right? Right now, next point. Next point. Using a digital voltmeter, using a digital voltmeter, a digital voltmeter is better compared to is better compared to is better compared to an analog voltmeter. Using a digital voltmeter is better compared to analog voltmeter since resistance of digital voltmeters since resistance means internal resistance of voltmeter since resistance of digital voltmeter is very high. So it absorbs a very small current. So it absorbs a very small current. Right. Listen, next thing. You will be asked whether using a resistor box is also possible instead of rheostat. Right? Take out again. Take out variable resistors. Right? We have only two types of variable resistors, two main types of variable resistors in labs. Right? Rheostat and resistor box. Right? Or is another giving the right? Right? Now, if that was asked about this class regarding this, what's the main difference between resistor box and rheostat? What's the main difference? What's the main difference? Rheostat is for continuous values, which means now since the range of rheostat is 0 to 100, which means any value in between 0 and 100 is obtainable using rheostat. Right? Rheostat can have a continuous setting because we are moving the slider down. Rheostat is a slider thing. Right? When you move the slider, then accordingly resistance changes. Right? Then any value from 0 to 100 can be taken for the rheostat. Right? There is one advantage of rheostat. And there are disadvantage as well. Disadvantage is you can't take the reading. You can make reading here. Or make it just not. But you can't say whether it's 10 ohms, 10.5 ohms, or 5 ohms. You don't get. That's a disadvantage. And about resistor box, what's the main difference? In resistor box, only discrete values are there. Resistor box flux and in these flux, the values are mentioned. So what you can get is the values that you can get, or the combinations of values that you can get by changing the flux. Right? Flux values change combinations with so that is called a discrete variable. Discrete continuous discrete and continuous variables. Right? Discrete means right only some finite values, right? For given values. can be there. When is our resistor box use කරලා මට කැමති කැමති value ගන්න බෑ. You can't obtain any value as you wish. Right? ඒකේ තියෙන values විතරයි ගන්න පුළුවන්. තියෙන combinations විතරයි. Right? 1 2 3 4 කියලා තියෙනවා නම් 1 2 3 4 කියන combinations ඔක්කොම ටික පුළුවන්. 1 2 3 4 ඊට පස්සේ 1 2 වලින් 1 2 3 add කරාම ඔයාලා 6 එනවා නම් 6 පුළුවන්. අන්න ඒ වගේ combinations එනවා. Right? අන්න ඒ combinations එක කොහොමද පුළුවන්. That's it. Right? මොනවද නම් 6.1 ගන්න we can't do it. That's it. Right? Now here the thing is this. We are changing current by 25 amperes. Right? अब 25 by 25 में change करें. Then to change the current by 25. Do we know the suitable resistance? එහෙම දන්නේ නැහැ. එහෙම කියන්නේ නැහැ. ඉතින් resistor box එකේ තියෙන resistor value එක මම change කරලා පස්සේ can we make sure that it is going to change by 25? එහෙම කියන්නේ නැහැ. Right? They get pressure now because just by looking at or checking at the millimeter reading, you can change this accordingly until your current changes by 25. There are क्या point है? Resistor box again order make sure run back because you can't change the resistance as you wish. Right? That's the thing. Yes, sir. नहीं resistor box use करना बोला क्या है? बोला back. Right? Resistor box cannot be used because we are changing current in 29 intervals. Right? How many intervals can the resistor box used? Okay, next point. Resistor box cannot be used. Resistor box cannot be used. Resistor box cannot be used. Resistor box cannot be used as the variable resistor. Resistor box cannot be used as the variable resistor. Things. Resistance cannot be changed continuously. Cannot be changed continuously. To change current flow. Continuously. To change current flow continuously. By 25 millimeter. Gaps. By 25 millimeter gaps. Right. Next thing. Now, when you start the experiment, now it takes some time for the thing. For the thing means to take 6 readings. Right? So after taking 6 readings, if we need to make sure whether the battery is discharged. Right? Battery discharge check කරන්න ඕන නම් අපිට ගන්න විදිහට තේරෙනවා. And මම මේ මෙතන explain කරනවා and we are using this same thing memory technique එක මේ technique එක මේ කරන වැඩේ අපි potentiometers වල meter use කරලා බලන්න පුළුවන්. ඒක electricity වල උඩ use කරනවා. Now if we need to make sure whether the battery is discharged. At the end of the experiment, right? What we do is we are taking the initial reading again. Right? Maybe initial value එකට set කරලා initial reading එක ආයෙ ගන්නවා. Right? Once you take the initial reading again, right? We can compare the voltage difference here again with the first reading. Initial value again after finishing everything. After finishing all 6 readings, right? We are changing this back to the initial value and going to take the initial reading again. Initial එක ගන්න පස්සේ ඊළඟව මොකද ඔයාලා මෙතන initial voltage එක ඇවිල්ලා දෙන්නේ for the initial value of current we work. The initial voltage has been the 2 volts, right? And after finishing the experiment, you are getting it as something like 1.4. You get discharge. And a considerable discharge, then the experiment is unsuccessful. එහෙම case එකක් නෑ. Right? You know the thing, මොකද battery එකක් දාලා ආයෙ වැඩ කරන්න. Right? If there is like 1.9, 1.95 ml එකක් කරනවා අවුලක් නෑ. Right? Discharge වෙන පුළුවන්. අර battery එක already discharge වෙලා වගේ තියෙන battery එකක් use කරනවා. new battery එකක් ගන්න ඉන්න අඩුයි. Right? So if you need to check whether the battery is discharged at the end of the experiment, right? In current electricity experiment, what we do is we are retaining the initial reading. Right? You have to retain the initial reading. Right? Mention the next point. To check whether battery is discharged at the end of the experiment to check whether battery is discharged. To check whether battery is discharged at the end of the experiment. To check whether battery is discharged at the end of the experiment. The initial reading is taken again. 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 And the value obtained for B, and the value obtained for B is compared. And value obtained for B is compared. And value obtained for B is compared. Right? Right. From that, you can make sure that the cell is discharged considerably. Right? You have discharged again. Right. So basically, that's it about this. Right. Basically, that's it about this. Let's quickly see what is given here in the guide. So comes the dash on the figure, and I just use that for the maximum resistance. Again, 100. Right. Decrease the line. Observe the reading of voltmeter. It open and record the value. Next, close the key while increasing the resistance of rheostat and varying the value of I by 25 milliamperes. As a standard, we say 25, right? But it can be varying from 25 to 30. Because all of them 25 to 30, yeah. Standard depth there 25. Number of oscillations we counting simple pendulum, right? Pendulum that in helical string. What's the standard count? The standard count here. Standard is 20. Standard is 20. Standard is 20. Right? Minimum 20. Okay, then obtain the 11 voltmeter readings along with the milliampere readings. Okay, but we against because conclude the discussion. Discuss the measures taken for the safety of the apparatus. Right? Measure for the safety of the apparatus means this fixing arm on. Right? We discuss here discuss. Although the causes of action taken to minimize the errors of the experiment. Right? Now, due to large current being drawn, for a long time, dry cell would get polarized and get discharged in a little time. The 10 ohm resistor is used to limit the maximum current. Right? Very important. We make a discharge. Right? Unknowingly. The key helps to flow the current for a short period of time. Right? Instant current. Instant current is not keying in. Right? Tap current. Right? Key tap current is other tap current. Practically used. Tap key current is body tap current is current fast and connect to it. Key tap current mother tap current like that. Key tap current. Right. The contact is the fast right. So however, the key has to be pressed sufficiently. And either and that can be asked because it is key is not that properly, right? The current is not passing properly. Current is passed, but not the proper current. That is to be passed. The contact can make a pass. Current is passed. That key has to be pressed sufficiently hard to keep a good contact. Since the internal resistance of digital voltmeter is much higher, the current through it can be neglected, right? You're going to take it. Hence, it is necessary to use a digital voltmeter for accurate measurement for the potential difference of resistance. Right. Okay, so that's it about the first one. Any questions? Any clarifications? Good. Online. Okay. I check a lot, just go through what we have done from the beginning and ask it as anything before we go to the next. Question based training program. Question based training वगैरह क्या हो इस right? And I said I know, but still that's yeah, the S2 one. They 19 was the last thing. They 19 or 19. Can I explain again why the Turkey issues like a career? Is it clear? Is it clear about the Turkey now? Right? So I think it's something else to go. All good. Right. Yeah. Right. I think it's part of that. Yeah. You got that? Hold. Dengar. Hai. Em bảo lại dia giống như cái. Okay. Anything else? Or not? Okay. Then let's